For our project, we required two additional data sources, that is immigration as well as standard of living. In order to get this data, we made use of the worldpopulationreview.com, which is our main website. And from there, we wanted tables from two web pages. They are immigration web page as well as a standard of living web page. So these two codes, that is WebScrape immigration.py and WebScrape SOL, that is standard of living.py, helps to scrape this information from that particular web page. It converts it into a raw file and finally displays it in a tabular format. It saves this tabular data into different CSV files, which is later used for all of our further data processing. Thank you.
Now we're going to scrap the QS ranking from the website page. And first of all, we use Selenium to remotely open the Google Chrome here. And we visit our target page, which is the QS ranking website. And in the arts and humanities subject, we have 5 subjects in total. And first of all, we have to accept this cookie button. And we would, and then we will store all the ranking. And we will store all the ranking of the school in this txt file. And then we will scrap from the last page, which is 51. And it will go to the last page and scrap the ranking and the name of the school and the location of the school page by page. So here's the full loop. You can see that it goes from 51 to 50, then it turns to 49, 48, and until the first page, and it will stop on the first page. After we scrap all the data from the page, we will get the data frame, and then we will remove some unneeded string from the ranking, and here is our final data frame for the art humanities subject, and we output the CSV file.
Now we're going to run the web scraping code for times higher education. We also have the 5 corresponding subjects for corresponding to QS. This one is for arts and humanities. The URL contains the JSON file, and we import requests JSON and pandas to grab the data and convert to data frame. Let's open the data frame. You can see that all the columns we wanted are here, and it's converted to CSV files. Here, with column names and everything well formatted. And we go back to the Python slider and we run for every subject. And we can see that all CSV files are here.
And now we are going to combine the data we have. So we have QS data, TH ranking, and each of it has 5 subjects, and the other one is standard living and immigration data. So we first read in all the all 5 QS subject ranking, and then we merge 5 data set together by their college name. And because there are some unique transformation from QS to THE, for example, in QS, the name of the school is called this, but when the school is in THE ranking, the name is called this. So there are lots of unique case that we have to transfer. And then there are some dots or hyphen or the in the university name, so we may have to remove this. And also we have to translate the university name because some of the name is typed in German, Spanish, so we have to translate it. And this will take some time. After we translate it, we will deal with another types of name transformation. For processing the QS data, we will process in the same similar way with THE file. We will read in the data we have and then merge 5 subject and then deal with some unique case with the college name that some name in THE coders, but in QS it is used a similar name but different. Then we will translate the college name in English too. And lastly, we will, and it will also take some time to run the code. After process QS and THE ranking data, we merged these two data sets together, and then we got the data frame with 5 subject ranking FQS and 5 subject ranking of THE and the school information from the THE website as well. And lastly, we read in immigration and standard of living data set, and then we combine them with the previous data set and output the data set as combined data.csv.
This is the V Education program. Upon entering the program, we're greeted with some text that explains what some of the values in the cells will be. These values come from the source data, so any not a number values were converted to -1 in the number of students enrolled column, and left is not a number in the ranking columns. So the flow, starting, you have 4 options. The fourth being to exit. The first option is to search by study field. When you choose that, you're presented with the supported study fields, which we determined from the source data. For example, we can select engineering, and you are presented with a list of countries. All these countries offer a school that has a ranking in engineering. So we can choose, for example, the United States. But if you enter a typo, it'll ask you to enter a valid country name. Upper or lowercase does not matter. And after entering the valid country name, you are asked to then filter your selection even further by the number of students. We will select between 10,000 and 30,000. And then you are presented with a list of the top 20 schools based on those filtered selections. So United States, engineering, and with a number of students enrolled between 10,000 and 30,000. And as you can see here with City University of New York and Indiana University, the source data did not have the number of students enrolled, and so we made the decision to include these anyway, as we believe it'd be better to give the user more options than less. So this program continues on a loop until the user selects the exit option. Looking at the flow number 2, search by university name. For example, we can type Michigan, and it returns the 2 schools that contain the text Michigan, and it includes all attributes for these texts. And now we will search by country, the third option. We're going to enter a country, again, with a typo. Let's write Chin, and I'll say country not found, and it'll ask you again to select an option. So if we try that again, let's type China. And now we have 4 options. We can display all the results. We can filter by subject field, filter by number of students enrolled, or filter by subject field and number of students enrolled. So selecting option number 1 will display all 16 results. Now let's do that again. We'll filter by subject field. We'll select engineering. Then we display the results. One thing to note here is that given the amount of data we have, the table is quite large. This project is being run in PyCharm, whose console supports horizontal scrolling. After quite a bit of digging, we were not able to find a way without, quite a bit of extra work in the way of installing packages and changing configuration files to get idle to support horizontal scrolling. Idle caps out at 80 characters in the width, so these tables will wrap. However, realistically, this program would not be run in idle. It would be run in a terminal or a program or an IDE that is not as technically limited as one is idle. So while here in PyCharm, the table stretches out for the entire width of the attributes, it will not do that in idle. Lastly, when you select 4, it will exit the loop and thank the user. Okay, thank you.